Hello. This presentation explains a study focused on producing biodiesel from used deep frying oil, often abbreviated as UDFO. The research, published in the Journal of Forestry Research and Management, tackles a key challenge in biodiesel production: the competition between biodiesel feedstock and the human food supply. Using waste oil like UDFO offers a potential solution. The main objectives of this study were to investigate the biodiesel production process using UDFO, model and optimize this process, focusing on the effects of process temperature and time, analyze the risks involved, specifically the uncertainty in the output, biodiesel yield, and the sensitivity of the yield to changes in temperature and time. To achieve this, the researchers used specific methodologies. They employed a statistical technique called de-optimal response surface methodology, RSM, to design their experiments and find the best operating conditions. For the risk analysis part, they utilized Monte Carlo simulations. The UDFO, sourced from local food vendors, was first cleaned and dried. Then, the transesterification process was carried out. This involved reacting the cleaned UDFO with methanol in the presence of a sodium hydroxide, NaOH, catalyst to produce biodiesel and glycerin. The experiments varied the process temperature between 50 degrees Celsius and 80 degrees Celsius, and process time between 60 and 180 minutes, while keeping other factors like the methanol-oil ratio and catalyst amount constant. Here are the key findings. The average biodiesel yield across the experiments was 70.13% by volume. Process temperature had a significant impact. Increasing the temperature initially improved the yield, reaching a peak, but further increases caused the yield to drop, likely due to the degradation of reaction components. Process time showed a positive correlation. Longer reaction times consistently led to higher biodiesel yields within the tested range. This suggests more time allows for better separation of biodiesel from glycerin. The researchers determined the optimal conditions for maximizing yield using their RSM model. These were found to be a temperature of 63.01 degrees Celsius and a time of 180 minutes, predicted to give a yield of 83.5%. Experimental validation confirmed this, yielding 83.44%, which is very close to the predicted value. The risk analysis revealed that process temperature is the more critical factor. Changes in temperature accounted for 87.4% of the variation in biodiesel yield, while process time accounted for only 12.6%. This highlights the importance of precise temperature control. The probability of achieving at least the average experimental yield, 70.13%, under the modeled conditions was high, calculated at 87.52%. In conclusion, this study successfully demonstrated the feasibility of producing biodiesel from used deep frying oil via transesterification. It provided an optimized set of operating conditions, 63.01 degrees Celsius and 180 minutes, for maximizing yield and quantified the higher sensitivity of the process to temperature compared to time. The researchers suggest these findings are valuable for understanding the process mechanism, designing better production systems, and potentially scaling up the process for commercial use. If you enjoy this paper digest, please subscribe to my channel and follow for more. Enjoy!